Hello and welcome back to the development of the Feersum Scheme compiler. So yesterday we were looking at implementing define library support for scheme libraries, and we got to the point where for a given example library, this libgreet library, we're able to compile it and run it, and it looks like it works, but the truth is that there is a certain amount of hackery going on to make it all work. So the aim of today's stream is to finish off the implementation of libraries, mainly by adding support for being able to import into libraries. The key thing here is that we need the ability to import scheme base, which is where a fair amount of the work is going to be, and then also undoing some of the temporary code. So at the moment, when we compile this down, the library doesn't actually end up in a separate type. The library is initialized here when it's defined, when the scheme specification says it should be initialized here when it's imported. So that's two problems. And then we're actually just always assuming that things that you export are globals, but that might not always be the case, because I think you can export things that were imported from another library. So we should instead, when someone says export greet, what we should do is bind the library and then have a look at what we've ended up with. And in this case, we would see that there was a definition for greet, and so export that rather than just fabricating a global definition for it. There's a bit more complexity that's going to go on there. That's the general overview. So let's have a look at what we went through in the last stream. So there's mainly work here in the binder. So we in the bind library, we have the library context. So this is a brand new binder context, and that's the first thing that we need to fix up, is how we initialize this binder context. So we have the binder context. We then bound the bodies. So we fix this up so that we are iterating through in the right way. Every time we find a begin declaration, we bind it in our library context. So that's gonna do all the symbol resolution and that kind of thing, and we'll end up with a list of bound expressions, which are going to be the statements that we should execute when the library is imported. And then we went through and calculated the export set for the library. So for every export declaration, we worked out what kind of export it was and fabricate a pair of name, which is going to be a thing that someone can use to look it up, and the value, which is the storage reference that it corresponds to. There's only one level of renaming that's supported on export, so that was a fairly simple thing. And then we add the library to the binder context, and this basically puts the library in a list that we can then look it up from later. We also added support for a global import. So there's this new node kind import, which you give it a list of things to import, and it just walks through the list, parses it as an import declaration using the same parser that we use in the libraries, and then it calls this add imports from set. So add imports from set is, it does find bindings, which is what we looks up the library, or depending on what you give it. So in this case, the imports statement would be something like only then test greeter greet. So to be able to add the imports from that, it first needs to recurse into this lookup to work out what the exports are from test greeter, and then it can apply whatever operation. So in this case, it's going to filter it down to greets, but there are other things that we can do, and that's what this find bindings method does. So if there was an error kind, we just raise a diagnostic for it. If you're doing an accept, then it recurses on the inner one and then filters to exclude. If it's an only, it does the same thing, but it just doesn't negate the filter. If you're doing a plain, this is where most of the complexity is. It basically does a try find on the libraries list to try and look up any library declaration you have. So it's just a linear search, looking to see whether or not there's a library name that matches, and then if there is, it returns the exports from it. If not, we raise a prettified diagnostic for it. Prefix just recurses and then concatenates the prefix onto the name. Renamed does a little bit of extra work here and filters it through this process rename function, which basically looks to see whether or not you have renamed each symbol, and if you have, then it changes the left hand side of the pair to whatever it's been renamed to. So that works, but as I say, the key thing that's missing from libraries is this hack, which is because we're just ignoring the import declarations, you wouldn't be able to bind the libgreet. You wouldn't be able to bind this libgreet properly because we're calling display a new line. Now we should be able to get those if this was a fully working implementation by looking them up from scheme base. Hello. Grammar boy. We've got, yeah, so we've got a fudge in place here, which just kind of imports everything that is in scheme base, and this is just a copy and paste of the create global scope, which is what's used to create the scope when we do the initial bind. This really should only be used for, this only really should be used when we're in the REPL or doing script-based things. So that's something that we should fix. In theory, if you're writing a proper scheme program, you should start out with nothing in scope. You should have to import, even if you want to do display or new line, you should have to import scheme base. And every library should start off with an empty scope rather than what we're doing at the moment. So I guess the first place to start is in bind library. Let's find that hacks. So let's start by deleting some code, and we'll delete the to do as well because it sounds like a good start. And instead of using that hack, we will do create with parent. So create with parent will create a new binder context, but the key thing is that we have this parent. Ooh, do we want to do create with parent? Because I'm not sure what we do with this parent bit. So it's normally used with lambdas. So you'll end up capturing stuff from the outside. Now we'll carry on using create with global scope then. But we just need to do map empty instead. So I guess the first thing we actually want to do is build up the base scope. So if we start out with map.empty, we can then just like do some stuff to fill this. Unless we start out with the library context being empty. Let's just break this method into 3 sections. Process, import. Probably should be one more dot there. Let. See, it really would be quite nice if we built up a scope and then passed it into create for global scope. So let's do that. Then do binder context can be initial scope. And we can probably like just make this lib context by doing this. I know that's effectively done absolutely nothing, but it's me thinking it through. Right, so then bound bodies will say process bodies of the library. That will also include things like includes and that kind of thing. But you can, so rather than just using a begin block, you can also have a separate scheme file on disk, but we don't support those. You'd be able to, instead of doing import, which brings something into the scope, you'd be able to include, which reads a file and then just takes all of the source code from that and pastes it straight in. But that's not something that we can do yet. And then process exports. of white space around this. So the idea here would be we'd start out with list choose list. Let's start a little better. List dot choose. If we get a import declaration, we do something, but for the time being, we'll just return none, and then everything else we just ignore. And then we do that pipe through map of C. I think that it can't work out what the type is yet. Oh, because it's an object list, because we haven't put anything in there. So I think what we want to do here is find the bindings. Bind a context. Bind. Yeah. Let's just make find bindings public. It needs to be public if we were going to do unit tests for it anyway. So we do bind a context, find bindings, and that's going to return us yeah, we need to find bindings in the parent context because we don't have any libraries or anything yet. That is now oh, we could let's do it this way around. So we want to be passing in the declarations and then filtering it through the choose. So then we end up with what? This function takes an import set what? Oh, it's saying it's going to produce a list of results. I'm starting to believe that it might have been easier to create an empty scope and then iterate through it instead. So let's do that. Just mutate it rather than trying to build up a definition. If it works, it works. Create a programmable scope, map, empty. And then instead of that, we can do library declarations. Then instead of doing map of seek, what have we got here? That just unhappy because I didn't do anything with it. Expecting. Oh yeah. I can do. Guess we can do a list.iter here. We're not actually building anything up, so we can just always return a unit. And in here, we want to do add imports from set. And that takes the binder context and the import set, which is going to be lib context now. And then I is just the import set. What is this doing? Yes, we need to match this so that we handle the error case. We get an error here. We're going to do I guess it should be in the library context. We should add the diagnostic. We're not going to have any position information, which is unfortunate. How did we solve this in the global one? I have a feeling that we just passed in the position. Yeah, so we do map error. On item.location. Maybe we'll just have to pass in the whole location of the library. So that wants to be node.location is probably the best we can come up with. And there's a red bit here. What is the problem? Okay, so we want to I Mr. Iter It'd be really nice if a framework exists that made compiler construction on .NET easier. Well, there's definitely libraries that help. So obviously I'm working in F# here, and in the syntax part we're using this library called fparsec, which is an F# implementation of parsec, so that we can write all of these parser combinators, which has turned out to be quite a nice way of parsing things. And when it comes to modeling compilers as a service kind of thing and IDE integration, I think there's a few NuGet packages that help out with implementing like language server protocol and stuff like that. Because I suppose that's one of the areas where .NET has an advantage, in that it's quite easy to write web apps in it, and language servers are really just web apps. I wouldn't say that C# is a particularly difficult language to write compilers in. I think the main problem with frameworks is there's not necessarily one best way to write a compiler. With things like game development, there tends to be patterns that are followed, but even then you end up with lots of different game engines that do different things, like ones that use entity components and ones that are a bit more object oriented. And I'm not saying it wouldn't be possible, but I just don't know where you'd start, where you draw the line, the abstractions. So if I run the tests now, I imagine this is going to fail because we're not going to be able to import scheme base. So 2 failures. Couldn't find library test dependency. Fair enough. That one I think we can fix more easily than the other one, which is going to be all about libgreet being broken. So let's go find test dependency. And here we are. So the problem here is import test dependency. You can't find the library, and I'm pretty sure that is because we are looking the exports up in the wrong place. We never copy the list of libraries across. So this binder context add imports from set is a bit... it's tied to a specific binder context. We kind of want to... yeah, we don't really... yeah, let's make find bindings is public. So all this is doing is finding the bindings and then adding them to the scope one by one. Do we have a way of just adding... we have add binding, which adds a return to the storage ref. This pattern of scope insert, it appears in a few places, and it might end up being what we... let's extract this as a method, and we can just call it scope insert. And that's just going to do this bit. Insert and there's already a framework called Flame. It has an intermediate representation and compiler passes for code optimization. There's something similar, isn't there, with expression trees, and that you can build those up and then have those compiled down to .NET if you want to. I've used those in some places instead of doing raw .NET IL. You can build up an expression tree, and they have some kind of support for compiler optimization, because I think it's got like a can reduce and reduce or something. Let's have a quick look around. Oh, it's just expression, isn't it? Is it? Doesn't. Yeah, I think it's this. So you can build up like expression, invoke, expression, blah, blah, blah. And then there's also, so you have a compile that you can call. Which returns like a func. I can't see that there. Yeah, lambda expression, compile. So if you build a lambda expression, you can call compile, and then this actually ends up creating a delegate. This is the stuff that's used for if you've got an expression. So let's do sharp lab. So if you do something like int whoops. That's also probably not what I want. Just a using. And then when you do foo.compile, you can then call it. And then let's inspect the result and run it. Okay. Actually, let's just get rid of that. No one writes main methods anymore. Oh yeah, alright, compile is not allowed. Fair enough. If you want to emit stuff to an assembly, there's like a library that Roslyn uses, but I don't know how general purpose that is. For what we're doing here in our compiler, we're using monosettle, so we basically create a type definition. It's going to be all the way down there here at the bottom. Yeah, and then we create like we create method definitions, and then where do we actually do the emit? Ah, here we call emit named lambda, which is our way of walking through the tree, and each one of these is going to end up recursing down until it ends up doing something like this for a sequence or an application. Or I would just directly call emit to put the right IL in the right order. So add argument binding. Is going to be scope insert context ID. Then we can do the same thing here. When we're building up the library, we can do the same thing. So we do context. I think that this is going to, because this is iterating over tuples, pairs, we can't just pass in scope insert context. But what it does mean is in the bind library, we can now do, instead of doing add import from set, we can do binder context find bindings, where OK returns the bindings. We can do the find bindings in the outer context, and then we can do list dot iter scope. I have to do another function for this because it's a pair ID storage binder context scope insert in the library context ID storage. So that's going to copy everything across. What's this upset about? Oh, I've got too many closing brackets. And then I think we can write this in a little bit more of an idiomatic way by doing result map and we'll map it with the list.iter without the bindings on it, like that. And then we can do map error for this. Which is just going to be diagnostics, context, emit, location. And then you need to ignore that to actually get it to be evaluated. And we're missing a closing bracket. So let's run those tests again, assuming it compiles. I have no reason to suspect it wouldn't. So 1. And this is where the more complex part is gonna be. So could not find the library scheme base. How about we switch out the old hack for a subtly different one. So whenever you create a global scope, we create a base library from it. So we'll do scope map if we do to seek, what are we going to end up with? Pairs of string storage ref. And then we can do name it's not pretty, but it might work. Yeah. So this needs to be libraries dot so it's declarations. Nope. Fields from inconsistent types. It's just expecting a list of string and a list of storage rep. Okay, so actually it just needs to be a pair. That's easier. Do pairs. The type. Oh, okay, so that's a seek to list. Now, anything that was passed in as the base, we just kind of assume is what we should be putting into the scheme base library, and then the scheme base will exist so that we can import it. And everything is back to working as it was before. Let's have a look at what's been changed and decide whether or not it's acceptable to commit. Scheme base and base lib, that's the hack we just did. Yes, scoop insert refactoring. That one seems pretty solid, to be honest. Nothing else here uses public, so that should probably just be like that. Down here we have basically all of the old hack is subtly adjusted. So now we are looping through the declarations and processing the imports to mutate our global scope. And we got the bit down here where we change how we call bind library so that we've got somewhere to emit diagnostics to if you do a bad import. Let's go make sure that library, there's some spec tests called bad library names, bad imports. How about we do define library test and then we say import why don't we just copy this, because it will work, as in it will be syntactically valid but semantically broken. Then if we update the snapshots, we should see a new diagnostic. I think it's going to be just covering the whole thing, which is not best, but okay. So spec tests are all there, and changes. Yes. So bad import. Yeah, we'll have that. We'll have all of those. We now have more diagnostics. It says could not find library test greeter. It goes from 3.1 to 4.42, which is going to be there to there. Nice. I mean, it's better than not having a location at all. The problem is that our semantic tree, the bound representation that we've got by the time we get to the point that we realize that your import declaration is bad, doesn't have any position information on it anymore. So, whole bunch of extra parsing stuff. Cool. Initial. Well, we can say add support for library imports. This or library declarations can import from outer context. That is contexts. Libraries. Hack to let's go mark that up. VS Code doesn't seem to be quite as on it this morning with the Git changes. So we have taken away one fix me and replaced it with another fix me, but it feels like it's a step in the right direction. We can now check off library imports because libraries are able to import other libraries. We just need what do we need? Yeah, we need to properly support scheme base. So I guess that's kind of the job of the built-ins module. So the built-ins module, this is where we actually like build up the core assemblies. Where does that get referenced from? It gets referenced from compile, so we don't actually load the types until we compile. Maybe it isn't the job of the built-ins then, because core macros. So this must be, yeah, create root scope. So core proc names and core macros. Okay, so it does find built-in. So these look like these are the ones that are used at binding time. Load extern built-ins. Just find built-in methods and then makes them into import references. Okay. We might want there to be like a built-ins object that actually holds the assembly that we can use for both binding and later on to emit. Or we have a list of some kind of like referenced library type. Anyway, I'm going to take a break and have a think about it, and I'll be back in a bit. And I'm back with a new hot drink. So, let's not tackle that straight away. Instead, we've got the import and export stuff done. Let's just move on to emitting libraries into a separate class, and then we can think about how we process library imports. So built-ins kind of mixes together stuff that we generate into the output assembly and stuff that we've referenced from another assembly. We've got this core assembly that we're loading our built-in methods from, which is basically just looking for specifically named attribute. We probably could probably do some of this with fewer references to the actual hard-coded types and make it a little bit more abstract, sounding like it might be a bit more of a complex thing. So instead, let's go tackle some of the fixmes, namely let's do not that one. Library bodies should be emitted into their own types. Slightly related to that. So the first thing I think we want to do is in the binder, we have this bind library. Processing imports, fine. And then we're binding the bodies. And then here we pick out the storage. What we really want to do here is look this up from the library context. So we have this lookup export. Rather than doing storage ref global, I think what we want to do is lib context. Oh, it's going to be binder context. Try find binding. ID. Oh, lib context. ID. And it's going to return an option. So we'll do. Yeah, I think. Well, a simple one is we can just return whatever it does have. Because that's going to be an option of a storage ref. And then instead, we'll have let make export ID storage ID storage that. Then we can do lookup export. Make storage. Make export. And the same thing here. We can do lookup export rename from. And then pipe it through make export rename to. The idea being here, we're now working on options. So we can get rid of that sum. Why can we not get rid of that sum? Ah, that needs to be option.map. I love the way that in F# you sometimes be halfway through a refactor and end up with so much red. What are you upset with now? Ah, that must be choose. Some. Let's try that again. hopefully that hasn't broke anything. The one thing we aren't doing here is we aren't handling the case where the lookup has failed in a way where you're trying and export something that you haven't actually defined. So an example would be here with test greeter. If we just do that, we'd expect that to have some kind of diagnostic attached to it, because so let's just update the snapshot to get the parsing to match, and then I'll have a go at fixing it up. Well, we can probably have so make export. This bit here is just the same each time, isn't it? So we can just move that inside. So we'd have ID extern name or something. And then we can just do that. But seeing as that is just option.map x call it X ID for external ID. That, I think, should end up doing the same thing. What's gone wrong here though? Not enough closing brackets. That needs, that's what went wrong. Then we'll end up with our optional list. What we want to do in here is, can we do option dot map Got 2 which maps what I would. Filter. Latin. Fold. No. I mean, we could just do. Let's just do. Let's just do a match. Because what we want to do is report diagnostic. So if it was okay, we make it an external ID like that. Otherwise, we will return none, but we'll also do lib context dot diagnostics dot emit or so we'll create a warning. We'll just create warning expect. I think it needs a location. And probably a message. Could not find exported item. Oh yes, obviously. Some so I expect this test to fail now because lookup export should be emitting a diagnostic when we try and do export greet here. Why did that not happen? Let's try running it. So it's debugging time. Feersum compile spec lib scm, and let's race the compiler to get to the binding. Paused on exception? What? File not found, but probably correct. Libs. Okay. Wow. Sometimes my inability to type surprises even myself. Okay, so exports is going to be library declarations. Let's do the raw view. No, let's do the... Okay, so there's no declarations here. That's because this is the first library. So let's carry on. Then same. Is this doing fizz buzz? I think that one should be fine. But let's step through in case. So fizz. That's fizz. Buzz. And hidden name, which we're exporting as external name. Good. Then we have the other library, which has got one thing, which is the export of plain greet. Lookup export here is greet. Could not find exported item. Okay. Warning. Could not find exported item greet. Okay. So it made it into the outer diagnostics. Yes. All good so far. Binding the library. Should be the last thing in the sequence. We're returning from bind. And then it says has errors. This should be false. It's going to try and emit it. So it's compiling the file. Hmm. What's going wrong here? I think this is a bug. I think the problem here is when we do compile, Parse the file. Then in compile, do bound and emit. I think this can be done. That should be returning the diagnostics. So the problem was that because emit could never fail, we were just returning an empty list of diagnostics. But we should actually be returning the diagnostics from the bind, regardless of whether or not we actually emit. So now that should fail because we should see the new diagnostic. Nice. And then we can fix that in there. In libs, we can fix it by doing begin define greet. Doesn't actually matter what we define it to. It's going to end up being unspecified, but yeah, that's fine. This is just failing because yeah, it's just failing because it passes differently. I was wondering whether or not we can actually make this do a little bit more here. So let's thread through. So we've got hidden name. So if we make hidden name something that we can recognize, and we're exporting hidden name as external name. So then if we import from example grid, then export greet, and we define greet. We do a rename here or prefix. Prefix is grid slash, and then we do grid grid / external name. And then here we can do import only test greeter greet. And then we can do display greet. So now, I mean, that test is going to fail again because it's going to pass differently. But we should end up with another test failing. There we go, because expected, but it got 101. So if we update the snapshots, I think that's library import and export working. And we'll do bad library names can have some bad exports as well. Or missing export. We don't. Update the snapshots again because we know it's going to fail. Right, what's the damage? That extra stuff, yep. That, yep. So we've got lookup exports. We've got, so we filter down the exports to only be the ones that we can actually find rather than everything, and report a warning if we couldn't find them. Fixing up the diagnostics that we returned from compile. Fixing up the parsing. Could not find exported item. We could not find exported item. Don't exist. So that's working the way we want it to. Bad library names also passes differently. Good. So, use binder for library exports. This ensures that items can be re-exported safely. I think the one slight issue here will be macros, because we don't actually don't know if we have a runtime representation for a macro. Maybe we do. Let's find out. Let's run the REPL and see what happens if I put a define syntax in. So what would an example define syntax look like? Macros, do we have? User macros. So you do define syntax, syntax rules, and then we'll have a rule which just matches the macro and returns a string, I guess. So that would look like define syntax foo, which is the name of the macro, syntax rules, no quoted things, any form which is on its own just becomes foo. That is the list of transformers. That is the syntax rules. That's the defined syntax. Okay, so foo is a thing. Let's go find out how external representation of it works. Okay, it's not happy about that. Invalid macro application. So you never actually be able to load the macro or move it anywhere to be able to export it. I mean, I think if you had a library and defined a macro in it and then imported it into another library in the same scheme compilation, you'd be able to use that macro. I think it's macros that are defined in external libraries that we don't support yet. But this is all getting sidetracked from the emit libraries to separate classes. So now we're actually respecting the scope that the original binder, we're respecting like the storage definitions from the original scope rather than fabricating them ourselves. Let's do some preparatory refactoring. So storage ref is kind of, I mean, it probably should be called, well, it's not really symbol. I don't know what a good name for it is. Sorry, I thought I was going to sneeze. Storage ref is something in, well, it's a reference to a place that it's the thing that an identifier refers to. So if you have a scheme program, let's go find just one of our random examples. Symbol equal, that will be bound to a storage reference. In this case, that's going to be an external. Same thing for new line. So we have macros, which we're not going to do anything with those. We have built-ins, which are what are produced at the moment when we scan the external libraries. So a built-in just means it's already compiled somewhere else. And they're not the same thing as globals, but I would like to unify them at some point in the future. The difference being that if we go to references, when you can't write to a built-in, and when you read from a built-in, it looks in the core types built-ins array directly. Now, there's a certain argument that maybe the built-in itself should contain the method reference, because it's kind of like an external method rather than you can't refer to a storage location. So when we have a look at globals, what happens is, for a global, we call load field. For a built-in, we call this emit method to func instead. So what we do is we load null because it's a static method, and then we create an instance of the func type and import our method. So it's slightly different. So like when you call new line, you're not looking up a static field called new line. You're looking up a method and wrapping it in a func, and every single time you reference it, you wrap it in a brand new func. So I would like to unify them in the future, because it can't be optimal. Anyway, locals, which are just looking in the current scope, globals, which is looking for static items on the program type at the moment, and that's what we're going to edit in a minute. Args, which are looking at the arguments array. Environment, which is a captured item from an environment, and a capture, which just means we need to look outwards into our capture chain. So every time a lambda captures something, you'd end up with a storage reference captured of storage reference environment of int and storage ref, which tells you which index it is in the environment and where it was captured from. And that means that when the compiler lowers all of the closures, it knows anytime it sees a reference to, say that was like arg2, it should actually look at environment wherever it got captured to. So what I'm going to do here is well, what do we want to do here? I think the simplest thing is to say string string. And that will mean that globals have a mangled type name and a field name. I mean, we never said anything about either of them being mangled or not already, but that's going to have broken a whole load of things. So let's go through and find out what. Scope insert. Yeah. So I think the binder context needs to have a name, so that anytime we emit a global, we can reference its name. So where are you referenced from? So in the binder, we create an instance, and in compile, yes, this should be context. If we do ensure field is looking program tie. Yeah. That's going to be a bit awkward. So we've got program type. We probably need like library types and then index into that by the name. So you do like context.libraries. Which means that the binder context needs to have a name, which shouldn't be mutable. So, mangled name. Then, when we create a binder context, if we let's see. So the mangled name will always start off as why we create great core crate for global scope. We could pass in a name, couldn't we? And just say that mangled name at the start is just name. Mangled name. We'll make it the identity function. We're going to need to come up with some kind of mangling scheme, so because scheme supports a whole load of random stuff in identifiers that we just can't support. Create with parent. So this is we have we don't have a name when it's a lambda. But you can define more than one lambda. When we get down to emitting, we kind of keep a counter. So it might be worth doing the same thing here. So in the binder, we have yeah. So here, let's do something like mangled name equals next mangled name parent. And then we have get next mangled name, which does next. Can't use a local count. We're going to have to use something the same. So next mangled name is going to do next equals mangles and then we are going to paste together the mangled name and the mangled count. What are you upset about now? Mangled name is not defined, but it kind of is. Local count again. Next mangled name is going to be. Shouldn't need to do that. Maybe if I compile it, I'll just be happier. Unexpected symbol. Well, that wasn't what I was expecting. Now we're just down to the places where we should put context mangled name into the global. Then all the places where we use the global. Okay, I think that's going to get a lot better when I recompile it. And then down here, we can just ignore the name for the time being. This union case expects 2 arguments. So you have to do it like that. Fair enough. Same here. I guess we could just paste the 2 together, couldn't we? That would... We'd still emit into the same type, but... lib context, because... Don't give it a name. But we could. So... Bind library. So we got library.library name. We can just use that. Probably. If you define 2 libraries, and is that gonna ever, are you ever going to have that clash? And then in the main, what's it set about here? String dot concat. Let's just rehash this a little bit. Just take the library name, categorize it together, and create a scope from it. There's going to be another place where we call create from global scope as well. Yeah. So we need to give it some kind of... I think that's what we use already. Nope, it isn't. Scheme. No, scheme program. when we compile, we come up with some fake name for the root type. It's going to be somewhere at the bottom, surely. Yeah, script body. So that's the default fabricated method. Okay, so it's just called Lisp program. Okay. This whole like create a type definition and create an emit context and go through and emit everything for it. This is what we're going to have to separate out into stuff that we do for the program as a whole and stuff that we do per library. But right now, find compile. Yeah, so there's some fix me's in here. Library names. So for the time being, we'll say mangle prefix. Whoop. Plus ID. Same thing for this. Idea there being, although we're still emitting everything to the same type, hopefully we should be namespacing things now so that globals from different libraries have different names. The proof will be in whether or not things explode. They don't. So let's have a quick look at what the IL that we emit ends up being. So the display one is kind of simple, I think. So spy IL spec no bin display DLL. So we have the environment object, which looks like it's not used. And we have our static main, we have the script body, thunk, we have what I assume is the script body itself. We don't have any static usage. Let's go find interesting looking spec. Swap it, maybe. Maybe not. Looks like there's going to be a load of stuff in there. Literals, lists. Go on. Fact will do. There's definitely something that's there. So we're just looking for there to be something that's exported into the global scope. So yeah, we have scheme library fact. And then actually let's have a look at lib. Lib should, or sorry, libs. So this should include some interesting named things. Yeah, so we have example grid fizz, example grid buzz, hidden name, not exported, and test greet to greet. Let's in the compiler. I'm going to make it the job of ensure field to deal with these mangled prefix ID pairs. That way, we don't end up with a problem where you're reading from and writing to a different location depending on whether I messed this up. I think that'd work. Let's find out. Then in the future, we can refactor it so that mangled prefix is used to work out which type, and then field is used to work out which field on that type. So that still works. Let's see what ILSpy looks like now. I've scrolled back too far there. Did I? Yeah, so that kind of works. That's, I mean, their names, and that's going to mean that different libraries don't end up trampling all over each other. We're still not solving the library initialization problem, which is the whole reason that we really want to put libraries into a separate class. But mangled names for libraries is a thing. Right. I'm going to take another break and I will have a look at refactoring the way that we compile. So now we have different names for each one of these libraries, and each one of the globals is attached to the specific library. We can start emitting different types for them. And I'm back. So I don't think we need to do anything different in the bind now, because we've got those globals coming back with their mangled prefix. But I think we do, because we don't have any way of tying back the library to the type name. yet. To bound expression library of string list bound expression list. So instead of passing in I don't think we actually care what the first part of this library is. So I think we can probably change it from being the library name to being a mangled version of the library name. Yeah, because we just ignore names so far. But we then could use name to create the type. So if we do that, well, it's just called mangle name, isn't it? So that should mangle name needs to take name, and it's going to do name this dot I could do seek dot map mangle name part, and then mangle name part, it could be the identity function for the time being, and then we'll do string dot concat joining it with a separator. Is there anything you can't use in an identifier? I don't think there is. I think we're just gonna have to come up with. I was trying to think, is there anything we can join things together with that you wouldn't be able to use as part of the scheme library name itself, so that we can protect people from name collisions? But I can't think of. I think the mangle name part is just going to have to go through the characters in the ID and transform them. So that doesn't need to do that anymore. We just do that. And down here, find a context, add library. I think that might be an old one. And then here, find scoop node. Where is this called from? It's called from bind. Maybe we just have bind. What does options have on it? It's a compilation options. Configuration and output type. Fair enough. That's not very interesting. Where's compile called from? This is going to be called from a few places. Not as many as I thought. Memstream. Output name, okay. And then here, stem. Okay, so I think output name might actually... Okay, it's going to end up being the assembly name. So let's have bind, take a name, and then we can do name Lisp program here. And then in compile, we'll have to do bind output. Like that. Then does that still do the same thing? That's an old error. Let's see what IL we end up with now. So you got the environment still, and we've got a libs.lisp program. Interesting. So What is that? What are we going to be ending up with here? Let's go to compile and emit library and then find out what we end up with. So if I get the debugger, crank open debugger again, we can run this with spec lib skim. Yeah, we don't need this breakpoint anymore. Don't need that breakpoint anymore either. So the name is it should support numbers. The body is empty. Test dependency, example grid. Test greeter. I guess the thing is, how much of the stuff in the missing the program down here can we move up? So well, I guess the first thing is how pervasive is this program type? Because if we can rip that out, we can move to having like library types instead, and emit named lambda would be able to effectively one is this bit here. So scope prefix at the moment starts up as root. But that would be like the library name. because it makes a call to the body method. We need to look that up at some point in the near future as well. So I think we'd want the whole like program type. We'd add the type. I think we can effectively treat the script body the same way that we treat the begin blocks inside a library. So both of them are just things that need to be executed. So in the moment we're relying on this emit named lambda, I'm wondering how much of this we can share. So core types, the root context. Do we want to create the root emit context and then have something which pass an emit context to that creates a child context and a type? Or are we gonna have to go through the whole list first to work out which libraries we need? We could kind of copy and paste this and then see how much we end up. Yeah, so let's do that. So let's just copy and paste for the time being. And See where we get to. So we need a new type. Output name. That will be. This is a namespace, isn't it? We can use context.scope prefix for that. Name. That is name. Making it a class. We're using object as the parent. Adding it into the types. Don't quite know why that needs the assembly, but there you go. Built-ins load core. We don't need to do that. And then, well, what does... libty. Create a nominal to contain for this library. Gotta get the comments up to date. So core, we can just take straight from core. Do we have a way in a mid-lane lambda? Do we have a way of making a child environment already? We explicitly need each library to end up with its own emit context, I think. Otherwise, we won't be able to work out whether or not we're at the root. So we can context dot. Every time we go into a lambda core, it's going to be. So I think we want to do CTX with IL's null. That seems sensible to clear out the IL processor. Don't want to override the debug documents. Program type wants to be the library type instead, but we need to work out what we're doing with all that. Don't need to copy that. Locals parameters. Emit symbols. We don't want to override that. Env size, parent env size, environment, scope prefix. Is that going to be name? Can't hurt. Don't need to copy the assembly over. So that maybe is a bit better. I think we need to do some more indentation here. That's the problem. I think that needs to be indented at least as much as the width. Oops. Library body parameters, bound.locals count. Well, yes. Bound.env mappings and bound.root. So what are they? So bound is a bound syntax tree. What does a bound syntax tree have in it? Can we just make it so libraries are bound syntax trees? Not easily, because that would make it actually recursive. So root is a single bound expression. Environment mappings and diagnostics. I think we're probably not. So a lambda has the int and storage ref list. So when we do emit lambda, we must be getting it from somewhere. So scope prefix doesn't need to be named. It can just be root each time. Because it's just used for formatting out the lambda name. But we have formals and locals. Env mappings is an option. I think. Because this is at the root level. We might know that local count is 0 and nothing should be remapped. So we could go with 0. Well, let's try it for the time being. Sounds like it might be a bit of a hack though. So locals count would be 0. Env mappings would be none. And root would be sequence. And let's just have it so that the binder does this for us. So instead of this being a list of expressions, a library is a string and the body. And then down here where we bind it, bound bodies, we will just make it into a bound expression dot seq. Does that compile? No. That's body. Yeah. And then down here, what we would do is, I think we just want to emit a call to the body. Yeah, I think. So this is still wrong. Because we're emitting the call at the point where the library is defined, not at the point where the library is imported. But it'll do for now. Program type is now library type. So how many places is looked up? Some. But methods is fine. It's fields that we care about. So program type can be the current type definition. We just also want to have libraries, which is immutable type definition list. Then we've broken a few places. When we create the root one, we can... Oh, no, it doesn't want to be a list, does it? It can be a map. Go on. We'll treat ourselves to a map so that we can look things up. Map from string to type definition. Then when we create this one, we inherit the libraries. That's fine. Down here, we've got program type, but we also want to set the libraries to be bear. Morning. It's not morning for that long here. Insert. So add takes key, a value, and a map. So yeah, let's go with, well, we need to know what the root one's going to end up being called, and I think it's going to end up being where do we call this from? Bind how about we just stick it in this thing? So how about we have mangled name, which can be context mangled name, and then instead so I actually need to add mangled name to this type. Then when we are in the compiler and wanting to omit, we can choose the mangled name here. So map.add found mangled name prog tie to map empty. So that should be a map containing just the program type referred to by its mangled name. We can probably get away with using bound mangled name here as well. And then when we do emit library, already getting given the mangled name. Scope prefix wants to be root here. But libraries, we need to add our type in to the library. So we'll do it here. Map.add name libty context libraries. So we basically mutate the global context and then we inherit it. So both libemit context and the one we've just come from should have that type in scope now. Then back to who looks at program type, and then we can change this out for library type in some of the cases. So we've got the definition here. Seek, try find. Let tie equals, they start off with context program type. We don't want to change it. And then here we can do context dot libraries dot you're gonna do map match map dot try find. Let's try pick. Try find mangled prefix. Some tie. I mean, this is an option and we just want to fail. So can we do something like option unwrap? iter is some get. I just do get for the time being. I was wondering about throwing a special error, but argument exception will be fine. We'll notice it. Does that compile? That is adding stuff to the fields, but it's doing it because it's initializing byte vectors. I think that might actually work. I mean, I'm fully expecting it to. Nobody uses other than Microsoft. Well, I'm not a Microsoft engineer, so I'm running .NET on a Fedora Linux. I mean, that's not great. Let's have a look at one of the ones that's failed then. Is it just failing to find the right type? Eval tests evaluate. So it's just where do we? It's going to be an eval, isn't it? I suspect that prog type is going to end up being null here. So I think what we've done wrong is back when we bound it, we did Lisp program here, and I think we don't want to put name on here. I think we can get rid of name. Or yes, we can get rid of name here. Put Lisp program, and then here we don't need to pass output name in. Because I think what we're ending up doing is that we were ending up with eval context list program, because we're passing eval context in here. It's a lot more passing. So let's have a look at the IL that we've generated. So fingers crossed, we now actually have multiple different. Here we go. This class is the greeter class for the greeter library, and it contains library body, thunk, and library body. We have example grid. We have test dependency. And it should support numbers. And it all seems to work. So the question then becomes, we did a copy and paste over here. How much of this is the same as the main body bit? So what would the inputs to be to this? You probably the name, this bit, which is the local count and any renames. That's kind of a little bit worried about that, in that I don't know whether or not if it's going to end up being broken if you capture things in a library. Do we have something? So we don't actually want to be don't want to be I don't want to be emitting that call there either. Could that be context dot program type dot? Because this is a type definition. It's taking the namespace. Do we have a namespace on here? Yes. So you could just steal that namespace to make sure they're all in the same one. There's a certain amount there that can then be extracted. So like create library type, which would take a name. Wow. Lib type equals create library type. We can do context.program type dot namespace name and context.assembly. We'll probably pass in context assembly first. Method to func show field. We actually have an IL helpers. Then we won't have the emit context. Do we need? I think we need the. I think I've just done something that's not going to work here. Because, yeah, that's modifying the libraries. That one. At least that bit will work. So down here, we're calling the body method. What I would like to do instead is emit unspecified. If we emit unspecified there, because that's when you're defining a library, this should then break some things. What we want to do instead is when you import a library. Okay. When you import a library, we will initialize it. If we can find it. which means when we bind a library, we can't use that nop anymore. So when you import something, so we'll have add imports from set. Find bindings. If you do a plain one with the library name, I'm going to return the exports. It's not going to be easy. What we really need to do is know at this point, when we return here, which library you've imported from. But because that's now like add imports. We could have this return. We could have find bindings return. Count. How many places do we use find bindings? Mostly just recursing. Add imports, and here someone doesn't import. We'd have find bindings, return a two, I would return a pair here, name and exports. Then that's fine. It does find bindings on the inner result.map. Everything's gonna have to do this. Fun name exports. List.filter. And it's gonna have to do okay. I know, this is just a map, so we'd have to build it back up again. This is awkward. Probably gonna need another bracket there. I mean, it's doable though. Go on, let's go through that whole thing. So the same thing. Basically want exactly the same code for the only. We're just gonna call it only and not it. Then name. It needs to be lib. Down here, we need another fun name. List.map. And then this can be fun name exports name then this is a result of list of strings and list of string storage ref pairs. So if it works, we'll get more information back. Then in here, we need to do result.map fun name exports. And then what we do is iter to insert them into the scope. And then return name. Let's add the exports into the scope, return the name. So now add inputs returns a result of string list, but we want to probably mangle that. Then down here, what are you upset about? Find bindings. Yeah, that's going to need to be fun name exports. It's going to do exports, add them all in, and then it's going to do name mangled name, then bound expression import. So now that is a result of bound expression unit, and then I think you can do result dot hmm. We can make this so it's an error of unit at least. So any error where the error type is unit, you can fold it down into an option. Of result. Kind of. Then list.iter, what we want to be doing here is choose, and that's an optional bound expression. And bound expression sequence. Now we make it into sum, and then make this into none, and then we can make this into a list dot choose, and then that means that it imports equals this whole thing, and then we can concat this and the bodies instead of just using bound bodies down here. Probably want them the other way around, don't we? And then in the compiler, we'll need to handle that new case. Let's find the libraries. That'll probably be the most logical place to put it. So let libti equals libraries name libti dot get methods dot just do it like this. So have some kind of initializers map that we can also look things up in. Codes call yeah, you're not happy. Initializers is map empty, and then when we emit the library, we do this context.libraries, then we got the body method, and then we do context dot initializers map add name body method. To the initializers. And body method is going to be a method definition, so we'll upcast it to method reference, I think. Good. And then instead of doing that, we'll do map match map dot I find name with some, if there is one, then we will call it we don't get one. It's not actually an error because there might be like a library that you've imported that doesn't need initializing. That's currently the case with the scheme base library, for example, because there's no body to run for it. So we'll just emit unspecified in that case. So we just fill out the stack slot. Try find name context import initializers like that. Okay, so I think we're back to the point where this should work. So the key thing here is that we're effectively doing nothing in this point and instead doing what we would have been doing there at this point one line later. So it should be completely indistinguishable, but it looks like some mistakes have been made. libgreet. So if libgreet fails, let's debug it and see what happens when we come to emit the imports and things. Which library? Test greeter. Go on, we'll have a look and see what this does. So it creates the type, adds the type to the libraries, creates an emit context, emits. Okay. Now what are we initializing? Scheme base. So this is not going to find anything. Then it is adding test greeter into the initializers, emitting unspecified. And then that's it. So we're never actually... This is going to be a binder problem, isn't it? So here, I'm putting all the imports in, but I bet for the global import, we're not. So if you do it at the root level, add imports, we're still doing an ignore. So this is now We map this with bound expression import. And this dot map, then we can do on result dot bound expression error. Take that and put that in a sequence. Is okay. And then here we want to say let okay or equal function okay. Run the tests. Close. Value constructor on namespace or type. Yeah, I mean it is. But why didn't that work? This is for it's in the libs one, I think, because it's doing greet. So we're trying to import from test greeter. So test greeter, when we run test greeter, should then import example grid. Import, try and find it, call the initializer. So let's have a look at the initializer on that library. So we've got the library body. example grid. An example grid should is it the greet one? Which one's? Yeah, I think it's the greeter that we need to be looking at. So greeter it's initializing. Have I just got those the wrong way around when I concatenated them? In bind library. I mean, it's totally expected. Must be this bit up here. Bound. Let's spec libs. So we've got the bound bodies. This is not the right library. Test dependency. We're wanting greet example grid. Test greeter. So we have the bound bodies, which is store blah blah blah, and we have the imports. And if I step out, we have bind library returned. Yeah, the store blah blah blah, and then import example grid. Good. So bind library just needs to be updated down here. List.append imports. Let's just do this. Bodies, then it's a bit clearer which around they are. Now are we back in business? There's a lot of green. Nice. So I think that's it. I think we're emitting libraries to separate types and properly supporting initializing things when they should be. The one thing we aren't doing here is we should have some kind of check to make sure that the library is initialized or not. Because at the moment, if you import a library twice, you'll end up running its body twice. But that's something we can deal with at a later date. Let's go through and see what changes we've got then. We have the new import. We have mangled names on the syntax tree. We've got the new name mangler. When we resolve imports, we return the library that we've imported as well. Then imports now actually produce a bound expression. So we construct a library out of both of them. Same thing for the global import. And we set the mangled name based on the result of the bind. In the compiler, we now have this list of initializers and map of initializers and map of libraries. We in ensure field, we look up the type first, and then when we find the type, we look up the field on the type. When we do an import, we try and find an initializer. If there is one, we call it, otherwise we were unspecified. When we're emitting the library, we actually create a type, a new context, and emit a lambda into that context rather than the global one, and store an initializer for it. Library is now returned unspecified, so when you do define library, you don't get anything back. And we use the mangled names, set up the initializers. So that's it, I think. We will say emit libraries into their own types. Binding tree now. And that's it. And importing of reference assemblies and loading libraries from metadata, which is what we'll need to be able to properly support the scheme base library, and all the rest of that is a job for another day. So I hope you all enjoyed that. Thanks for watching, and I will see you next time.